So as we wrap up our seasonal series today, we wanted to dive into some of the developer basics, and we have a couple of different topics that we want to go off. And Brian is going to lead us through the first pieces. And I think we are going to start with data types. Do I have my agenda right there, Brian?
That is correct. Did you want to wait till the end to go over the conversion and the performance issues, or did you want to tackle that before you pass it off to me?
I'm actually going to pass it off to you, and then before we go into the next piece is when so we will
okay.
Kind of stop and start a little bit there.
Okay.
Okay, but it looks like, Brian, I can see your screen, so it looks like you're
okay. Great. Yeah, it took a while to come up.
Yeah.
Just a brief introduction to me. Like we said, my name is Brian Combs. I'm a database developer. I've been working with databases forever. Actually started my career as an accountant and worked for a small company and had to manage their systems as well as figure out how to write reports, and got very interested in that. Started learning how to do SQL on my own and decided to go back to school and get my computer science degree in my 30s. So I've been consulting for about 3 years. Actually, it's about 4 years now. I need to update the slide, and I just put a little information, my LinkedIn and my Twitter account down there.
Yeah. We roped Brian into presenting with us at Past Summit last year, so that was a fun experience, right? So some of this material we used there. So
right, and today we've got only a short time to talk about some of the developer essentials, but we thought we'd touch on data types, some query basics such as, and under that we're going to touch on views, stored procedures, and functions, which are three of the big things that we use when developing, whether it be through a true programming, or if you're doing some business intelligence development or even report development, those come into play a lot. And then lastly, we're going to talk about some ways to pull in data that you're going to access a lot. So instead of querying the full database every time, you can pull it into a temp table, temp table variable, or a common table expression. So we'll touch on that as well. So let's talk about data types first. I'm only going to touch on some of the more commonly used data types here. There is actually more than what you see here. But generally under data types, we usually talk about, let me go back one time. We usually talk about, there's 4 types of data types. There's numbers, there's strings or characters, there's date and times, and there's true, false values or Boolean values. So under the number values, one of the more commonly used one is int, which is just a whole number. Basically anything that doesn't have a decimal point. I didn't put the range of values out there. I believe Carlos, help me out. Do you remember what the max value is you can do for an int? It used to be.
Yeah. So what is it? 32.
Yeah.
Million, right, something like that.
Yeah, something like that. So if normally you don't have a problem, but if you do, you might have to use a different data type, such as decimal or numeric, which there are 2 different data types. One's called decimal, one's called numeric, but they're actually pretty much referred to as the same. And in fact, I've never actually used the numeric value. I've always used decimal. So that's kind of what we're sticking with here. The decimal can have as many decimal points. Basically, I think it's up to like 36 decimal points, I believe, and then you have to go to a float data type, which I didn't list here. And the general consensus is, unless you really need to go out past 30-something decimal points, don't use float.
Yeah.
So use decimal and what goes in the parentheses there on the second bullet point is decimal. So in my example, I have 14, 4, which means I have a length of 14 with 4 decimal points. And that could be much larger than that, but that's just the example that I'm using. So that could be, could be 20 with 8 decimal points. So after that, we're going to talk about the strings and characters. And a char, very rarely have I ever used char, but it can be useful if you want like a set number of characters that it's always going to. In this example, if you have char 1, it's only using one character, and the varchar is what I normally use, and that is a variable length where you give the maximum number of characters. So in this example, varchar or varchar, a lot of people say varchar. It's basically just a variable character length, and in my example, I made it a length of 15, which means I can't exceed 15 characters, but it can be 1 to 15, and they don't all have. Not every character has to be filled in, so to speak. I mentioned varchar or varchar here, and the N is used for Unicode values. So basically, if you're working in a system that is using multiple languages, you want to use the N, which basically tells you to use Unicode, and it uses a little more storage space. But I think in today's world, with the disk space that we mostly have, it's usually not an issue. But if you're only using one language, if you're always working in English, then there's really no need to have the varchar. And then the fourth is dates and times. So a date is just strictly your month, day, and year, and based on your system setup, your settings in SQL Server, that can be formatted in different ways. But one of the standard formats is your year dash your month dash your day, and of course Europe does it differently. So it always, whenever I'm working with something from England or something, I always get confused with the day and the month. The time is just the actual time part, and it goes down to hours, minutes, seconds, and then what do we call the last part? Milliseconds or
microseconds?
Microseconds is probably the better term for it. The date time data type is basically just a combination of the two. So it includes the date, and that actually, I forgot to put the microseconds on that, but it does have the microsecond. Whoops, let me go back up here. It does have the microseconds on it. Date time 2 is another date time, and I've never really used it, but it has more precision than date time. And Carlos, I don't know if you have any instances where it's better to use date time 2, but I've always just used date time. And there is a date time offset, which is basically your date time, but it includes the UTC offset. So if you have locations around the world, and you want to know what the date was at that location at the time of the entry, you could use that, which I have not used. And then the last data type is your true false values, or your Boolean type values, which generally you would use a bit, and 0 is false and 1 is true generally. That's what I always program it as. I guess in reality you could make it what you want, but that's in your development, that's generally what it is. So Carlos, do you have anything else you want to add to the data types?
Yeah, so data types matter ultimately because we talked about last time, SQL Server needs to know is responsible rather for getting the information, and the data types give it descriptors on what kind of information is there and how it should deal with it. And so one of the things, in fact, are you done with data types, or are we going to jump over into the conversion pieces?
We could jump over the conversion pieces if.
Okay.
if you're ready, because that's really where this kind of leads to.
Yeah. So earlier we talked about, let's see, can I share?
You want me to stop presenting?
Yeah.
There you
Share screen.
And while that's coming up, I will mention that one of the databases, if there's any EPMS customers online, you'll see the money data type a lot, which apparently was used to try to save a little storage in the past, but it's not commonly used that much now. And normally you would use decimal as opposed to the money the money data type.
Okay, so remember we talked about SQL Server wanting to get back information. So here I have a query, or SQL Server is responsible for bringing this information back, and how data types will affect it, or how it interacts with different data types. So here again, some fairly simple examples, but I am running this query here. Right, so I'm selecting two columns from a table where is finalized like, 1. Now, if I go over here into the, I want to look at my execution plan. So I've turned on the ability to get the execution plan. Again, we talked about in a different session, or last session we talked about that. And you'll notice I hover over. Oops, it's moving around a little too much. I can hover over and I see this warning sign here, where it's saying that it has an implicit conversion. So what is going on here? Well, in this specific instance, it appears that the is finalized. Let's take a look here. I guess. Let me see if I can see that a little better. Yeah. So here it's telling us that there's a complicit conversion on transaction ID, the is finalized column, meaning that, hey, the data type you're passing me and the data type of the table, when I'm doing my comparisons, they're not the same. So then SQL Server has to then figure out or do a conversion to be like, okay, let me convert this data type to the other, so I can actually make the comparison. And that can then be costly for SQL Server. So if I go over and I take a peek at this table, I can see that the is finalized is actually a bit column. Right? So it's a computed bit column. But up here, what I am passing is ultimately, right, a character. I have a string. So I know we just talked about in SQL Server Management Studio, I see the red, I know that I'm dealing with strings. So what I've had to do here is I've had to convert from a string into a bit or a number. Okay. Now SQL Server will do that for you. The challenge is that it has to do that for every single record that it processes, and that can be cumbersome, right? Or that can take some additional time. Now, so one of the ways that we can go to look to fix that is, what is the table, right? What is the structure of the table? And ideally, I want to match my criteria to what's in the table. Okay, so in this case, it's a bit. I know that it's a number. So here I want to run, I can change it. Now you'll notice, so one of the issues that I have is that I have to change from a like to an equals. So my logic has to kind of change here. So one of the things we then need to figure out is that okay, right? Sometimes there are business logic reasons that I may have to think through that a little bit more. And I don't, it's a whole lot of it depends. However, these are some of the thoughts that you have to start going through when you see this. So now if I change that to just equals the 1 and I look at my execution plan, you'll notice that that select is gone. Okay. Now, occasionally, you may, like, for example, working with the dates, right? Your UK customers, we want to see dates in different formats than your US customers. And that will happen from time to time. One of the biggest, or my suggestion is that we want to avoid complicit conversions on filtering and on join criteria. So anything SQL Server is using to remove selectability, those are going to be the big ones that we're going to want to remove, or at least try and resolve, right? Is there a different way that we can do this? We do see, however, I've taken the same query, I've added another column, and I have added the transaction date column. Let's see. Okay, and if I want to run that, take a look at my execution, you'll see that I still I am still going to get this warning saying, hey, there's a complicit error on my transaction date. However, right, it's that transaction date's not being used in my filtering. So I don't love it, but I'm reducing the amount of work that SQL Server has to do to be able to make decisions, right? So again, just some considerations there. Does that make sense?
Yeah, and I think the like command is always looking at a var, at the character value, a string value, like you said, and when you, on your first example, the like was on a bit, would be the same if you're doing it with a number. So it would have to convert the number to a varchar before it actually processed it. So just keep that in mind.
That's right.
And a lot of times using functions. I'm sorry, Carlos. So a lot of times using functions in your where clause or your joins can create some performance issues as well. So you try not when at all possible, try not to use a function in the where clause.
Right. And I guess we'll get into that one actually when you go over those. We can revert back to that.
Right.
So again, I think the takeaway there is the SQL Server will take care of converting from one data type to the other, but those conversions aren't free, and we want to try one common element is we want to try to remove them as much as possible. So
one of the functions that I used to be guilty of using a lot that I found actually has a bit of a performance hit is the date diff function. I was just bringing this up while my screen was coming up. So I used to say, like, where date diff, the record date compared to the get date was greater than 3 years or something like that. And through just doing some performance tuning, I found that it's actually better to do like your record date is greater than a variable or less than another, another, like the begin date and end date if you passed it values. So since I realized that, I try in my current to do my best to not use the date diff function in the where clause. I still use it in a select statement when needed, but anyway, just thought I'd mention that. Okay, so after the data types, we're going to jump into just some query basics. And my assumption is that most everybody on here has been through some of the basic query training sessions that we've had, or is simply knows basic syntax of a select statement, maybe an update statement, delete statement. On my slideshow, I listed some basic syntax of some of the most popular commands that you'll use in SQL. So if we need to, just mention in the chat if you want to touch on any of these more basic concepts, because otherwise I'm going to skip into looking at some of the developer options such as views, which will be the next slide. So Bill asked, is there a hierarchy of data types?
Yeah, so there are data types that SQL Server will convert, right? So this implicit or explicit conversions. And I'm actually going to put in a link here if you want to take a peek. They have a graph. Right, that will show all the explicit and implicit data type conversions that are allowed. Right, so sometimes SQL Server will say, yeah, I will do that conversion. Sometimes it won't, and obviously those are when we'll have problems. So in that sense, there's a hierarchy or a way in which data types will which ones will work together and which ones won't.
Yeah, I don't know if hierarchy is the correct term, but it's a sort of hierarchy.
Right.
So that's there for everybody to grab to look at. And having said that, I'm going to go on to views. So there's really three types. Well, there's three types of I don't know what the term is I'm looking for here, but procedure. So here I'm listing views, procedures, and functions, which as a developer you're going to use quite a bit from the SQL development side.
We're really just encapsulating logic, right? We've written logic, and now we want to be able to extend that either for others to use or to make it in an application so that our applications can use it. We're creating abstraction, right? So the underlying tables might change, but my application can still interact with these things and be none the wiser. I want to make application changes later.
Right. As a programmer, you know that you want to reuse as much code as you possibly can, and object-oriented programming. That's what that's all about. In SQL, it's not as straightforward, but by using these methods, that's kind of a poor terminology, you can reuse your code.
They're really objects.
Objects, right. Objects is the right term. So first, a view, and I grabbed these from w3schools.com. The SQL is basically a virtual table based on the result set of a SQL statement. In short, it's a saved query. That's basically what a view is. It contains rows and columns just like a real table, and you can query it. You can query the view just like you would a normal database table. And where I've really gotten a lot of use out of views is in business intelligence, in a lot of my business intelligence development, because if you're loading a data warehouse, or if you're repopulating a report on a nightly basis, views can come in real handy there. The one thing to know about a view is that you cannot pass a parameter to a view. Now, a stored procedure, the definition that they give us is it's a prepared SQL code that you can save so the code can be reused over and over again. Very much like a view, but in this case, stored procedure, you can pass a parameter to it, so that if let's say you wanted to know the dogs that belong to a certain customer, you could you could have a stored procedure that took in a parameter of the customer, and it would return all of the dogs that customer owned. Now the third object is functions, and I'm only going to touch on the user-defined functions, the scalar user-defined function that is in this. That's the one that is mostly used. Now there are other types of functions. There's table value functions and so forth, but that's really, for the most part, you're going to use scalar user-defined functions, at least at the beginning of your development career. Now, as you go forward, you'll get much more into the table value functions. So the UDF scalar functions are basically.
I need to jump in there and say the table value functions are ultimately ideal. Now, SQL Server has made some improvements in the scalar functions, right? But we'll wave our red flag and just say generally, when I see a scalar function, I'm like, oh, there's a problem.
Right. So anyway, the usually user-defined function, you're going to use it to do some kind of calculation or to return some value. Now, the example that the definition I got from Tutorial Gateway basically says it allows to create our methods called as user-defined functions. For example, if we want to perform some complex calculations, then we can place them in a separate method and store it in the database. So that basically means if you got a complex calculation that you want to, that basically you're going to need the call from in the query, you can store it as a function, and it'll pass the whatever value it needs to do the calculation onto the function, and it'll do the calculation and return the result back to you. So. Does that make sense, Carlos, or do you have anything to add on the functions?
Yeah.
Okay. So from there, I'm going to jump over into some examples, and bear with me for a second while I bring over my SQL Server Management Studio, which you all should be very used to, since that was one of our previous sessions. So let's talk about views first. So view, as I said, was simply basically a stored query. I'm using our Learn SQL database, which is actually came with Carlos's book. That how long ago did you write that book?
So 6 years ago.
Sounds like we need an update.
Yeah, that's right. You're not wrong.
So built into this whoops, sorry about that. Into the database is this. Where am I going here? Create to is this random B view that I think Carlos may have done. So basically, all it's doing is selecting a random value. Now, what we could do is take any of our queries, such as, let's see. So I've got this one query here, which all it does is selects the pet owner and tells us whether it has any dogs or has any cats associated to it. Now, what we could do is create a view out of that. And this may be a bad example as to why you would do this as a view. And actually, what I really want to do is just take this and create the view. Oh, don't tell me my computer's locking up here.
I think you're in create view in the WYSIWYG rather than in a new session.
Oh, yeah, that might be.
Query.
Okay, hold on one second. Bear with me, guys. Like Carlos said, I'm coming. Let's just close that guy. Create a new query. I'm coming back from a cruise, so bear with me here. So if I took this simple query and say I wanted it I wanted to create a view out of it. So basically, a view is a saved query that you can call at any time, and I could call this the pet owners or something like that, and I can just create. Yeah, select star. Hold on one second. I need to do like I normally would and go here and hit. Remember, you can script anything, whether it's a table, a view, a stored procedure, and reuse it, which is what I always do. So what I forgot was the as right there, which was really dumb for me to forget that. But a lot of times I'll just pull up another one and remove the core of it, and then column names must be unique, and that's because, so let's just say and I'm sorry about this, guys. Here, hold on one second. So I'm just going to create owner name and dog identifier and breed of dog and name of dog. Now I'll do cat identifier, breed of cat, and name of cat. So I've got this little simple query here, and I want to reuse it. I want to be able to call it anytime I can without retyping it, so I can just create the view. So it created the view. Now if I want to call that same query, all I have to do is select star from the pet owners. And voila, there's that same query. Now, the other thing about the view is I can, if I wanted to, I can actually throw a where clause on this just like I would with any query against a table. And as you can see, this view has actually got 3 tables involved. It's got pet owner, dog, and cat. So if I wanted to say where owner name equals John Smith, so I get just John Smith there. So basically, a view is a saved query that you can query just like any table, and you can put a where clause on any of the column names, or you could even include. You don't have to include all the columns too. So that's basically a view in the very basic format of it.
So one of the areas that we see folks getting into trouble is where, because again, you have this logic, and obviously this is our simple example. But let's say you had a view that you had to scroll down a little bit, a couple of times to see the end of. Well, what we'll see happen is that they'll create views on top of other views, right? Mm-hmm. So now it'll be, I don't know, view v pet owners _2, or maybe not 2, that's not the right answer, but view all pet owners or something like that, right? When you're taking some of that logic and then you're trying to do something else with it. So nested views are a quote unquote issue in SQL Server. So anytime you can take that logic, again, we talked about reusability, in coding, we want to be able to do that. SQL Server reusability is not necessarily our best friend here. So just something to keep in mind as well.
Okay. And now remember, a stored procedure is basically kind of similar to a view, except that it accepts parameters and returns. And let's just walk through one here real quick. So if you go under in SSMS, if you go under programmability, you'll see that you've got your stored procedures and your functions down here. So if I want to create a new stored procedure, it'll just give you the basic syntax. And let's just take our query that we just did, and let's say that we wanted to make this a stored procedure. And what we want here is we want to be able to call a stored procedure and return all of the dogs and cats for a specific pet owner in this case, kind of like we did here, except in this case we're going to call a stored procedure, and that will come in very handy. So for this one, we want to create our stored our procedure name, and a lot of times you'll start with SP for stored procedure. Now other people might do it differently, so I'm just going to call this owners pets, and we need to receive in a variable, or we need to receive in a parameter, and the parameter is going to be the dog owner. And in this case, I could use dog identifier, but most likely our user is going to know the owner's name and not necessarily the owner identifiers, which is what I meant to say. So we're gonna make use the varchar variable or varchar data type, and I'm thinking that none of the dog owners are going to be longer than 50. So that's one of the things you need to be aware of as you set up your data types. Is you want to make sure you make the length of it, in this case the string or the varchar, you want to make the length of it long enough to hold the maximum value you're ever going to put into that column. So in this case, I'm going to just create my dog owner, and I'm going to pass it. I'm going to pass the dog owner, and then I'm going to come over here and I'm going to just say I want to do the exact same query that we just did as an example, but in my where clause, I'm going to say where the pet owner dot owner name equals the dog owner. And what this is going to do, it's going to create a stored procedure that I can call at any time, and that doesn't need to be there. From cat. And I'm curious as to why this is what happens when you do things on the fly here. Incorrect syntax near you have the parameters. What did I do wrong here? Carlos, hold on one second.
Okay.
Hold on one second here.
Oh, is it the data type? Does it? Oh, we have a data type, right?
I've got the data type equals procedure name, parameter 1. So it's saying that for pet owner name.
Oh, is it the as? Did you add that? No. Create procedure.
No, that's there. So, okay, well, this. Let me just. I don't understand. Create procedures, pets, the procedure name, and then the parameter value. And select. No count on. This is really bad. Let me just pull up a different. Let's do this. Create procedure. Begin. Set no count on. Whoops. Execute. I'm going to get the same thing. Do I need to have? Okay, guys, this is really embarrassing, but I'm having a problem here. So let me just do one thing here real quick. We don't have any other different stored procedures in here. The procedure as equals null. I'm not exactly sure. Inner join, outer join. This dog owner, varchar 50 equals. Okay. Well, let's get back to that, Carlos. I don't know. We can follow back up on this one. Let's just say that a stored procedure in the way that you would normally call a stored procedure, and is you execute. So instead of, when you saw how we called, where we called the view, select star from, and then we said pet owner, or from the name of the view. When you do the stored procedure, you're going to execute, and you're going to give it the name of the stored procedure. So let's say owner pets, and then you're going to pass it the value for the variable, for the parameter, and that's how you process a stored procedure. Since I completely bombed that, let's jump over to functions real quick. And a function, like I said, is a way to return a specific value. And let's get back to where I was here. So that's the random v function create. So the way you create a function is very simple, similar to how you create a stored procedure. But in this case, I actually was able to create it. So I pre-created this one. So what I want to do is return how old the animal is for each animal when we do a query against, whether it be the dog table, the cat table, whatever table we want. So in this example, I created a function. I'm going to pass the birth date, and all it's doing here is I'm declaring the age, and I'm setting the age equal to the date difference. And I'm only returning the year value of his age. You could very, very easily return a decimal point, or you could return the months or whatever. In this case, I'm only returning the year value. So that creates a function called fn underscore animal age, and you can see I already created that. So then when I go to actually select the function, so I can actually select from the dog, and I can pass select from dog, and I'm going to return all values, but I'm on top of all the other values, I'm going to return the birth date of the dog, which I'm calling the function that I just created, passing the birth date of the dog, and you can see that, and I named it age, so you can see that it returns all the values of all the columns of dog, and it also returns the age. And we've got a world record here, I think, of a dog that's 44 years old. He's yellow. His name's Odie. So
Odie from Garfield, right? That is the age of Odie.
Right. So a function, as you can see, a function could be processed for every record of a query, which is generally how you could do it. It could be used in where clause if absolutely necessary, but as we talked about before, performance could be an issue with that. So this is really stored procedures and functions and views are really valuable to reuse your code. So that's my brief description of that. And
so Brian, I think I have something else I want to try on your procedure, and based on the engagement, it is nice, right? So one of the wonderful things about the seasonal series or the SQL Trail experience is that we get to all learn together. And I think what our issue actually is we need parentheses on each side of the procedure. So I think you can actually remove that equals, but we want parentheses on either side. Yep.
Regular parentheses?
Regular parentheses, yep. Try that.
I'm thinking that's not going to work.
You don't think that's going to work?
No, because I've never used it.
Click
yeah, I've never used parentheses before.
Really?
Yeah. So it's saying here, let's click. So here's the thing that you can do when you click on your arrow down here. It takes you to the line of code. I mean, it says what line?
Oh.
Line 20 there, but that's kind of misleading because it doesn't count the blank.
We deleted the end before the go.
Oh, that's it. That's it right there. Somehow I deleted the end. I don't know how to
Hey,
do the
Max, I know we didn't offer t-shirts today, but you get a t-shirt.
Right. Okay. So let's execute that guy now. Oh my gosh, it worked. So who told us that, Max? Thank you so much.
Max.
Sometimes somebody
It
looking
has
over your
become the
shoulder
teacher.
right. So then we could execute that if we wanted to. So we could execute, or exec works too, and we're going to execute our, what did we call this guy? We called it SP owner pets. And it has and if you hit space, you'll see, your IntelliSense will tell you what it's looking for. So it's looking for the dog owner, which is a varchar 50. And I'll just do John Smith again so you can see that we basically got the same 2 records that we got in our view when we queried it based on John Smith. So that would be helpful if you have if you want to put something out there, or if you're creating a report and you want a parameter. Stored procedures are used tremendously, like in Crystal reports or SSRS reports, as the data source, as opposed to just directly linking to the tables. So it allows you to create your full query and accept the parameters and return the results. Now, having said that, we were going to touch on temp tables, and we're almost up against the hour. So
Yeah,
do we want to briefly talk about that?
I just texted you a link. Would you bring that link up? And we answer Ryan's question here. Does it still execute without the additional? Oh yeah, parentheses. Yes, I'm sure that it does. The end was definitely the issue there.
Right. So do you want to just go over this? Or?
Right, so a plug, right, for our podcast. So for those of you who don't know, we also have a podcast, and we have to go into the Wayback Machine, right? We're talking with Wayne Sheffield, and we have an episode. Now this is all audio. We're not sharing it. We're not sharing screens or anything. But if you want to take a peek, episode 49, we actually go through. Right? Yes, Luther. So especially since we're approaching episode 250, right? We have to go into the Wayback Machine. So you can go onto that page and you can listen there to the episode if you'd like. So we are certainly we can certainly stick around for a little bit. But again, as Brian mentioned, we want to be mindful of your time. If anybody has a specific question, then I suppose I will go ahead and cheat. Right, skip to the end. Now let's
go back to that.
They have made a change in 2019, and I'm still not quite sure that it is there. But if you're having trouble, all your followers get a free T-shirt when you hit episode 1000. Sure, we'll do something special then. But right, so the spoiler or the show notes version is, if you're using a table variable and having problems, try a temp table.
Right, and I brought up my last slide here so we can just briefly touch on this. So temp tables, they start with the pound sign or the hashtag, whatever you want to call the that icon. You have the single hashtag, which is a temp table that's only available to your current session that you're working with. You also have a global temp table, which starts with 2 pound signs or 2 hashtags, and that can be accessed from anywhere. So for the life of that temp table, that can be queried from any other session as well. So that's one good thing to keep in mind. And the temp table variables, basically, we discussed that. You normally would use temp table you usually use the table variable if you have a limited number of records that are going to be pulled into the variable. Otherwise, it's usually more beneficial to use the temp table if you have a large number of records. And we were going to talk about common table expressions, but I think maybe we'll leave that for another session. And I'll just briefly explain the cut. Yeah, it's basically a way to bring in a set of data that has to be part of your current query. It has to be in line with your query for it to work, whereas a temp table lives until you either end that session or you drop the table.
Yeah.
If that makes sense.
Okay. Well, as always, you will be getting shortly. You'll be getting a link right in your email to a survey. We'd like to know your thoughts about this and the other episodes, particularly if there are topics you think we should be covering. We're also very interested in that. So with that,
and you can tell us how in the world could you miss the end? How did you delete that and make that mistake?
We actually meant to do that at the end, right? Dun, dun. Yeah. Very good. Well, thanks everybody for being here. It's always good to see you. Be good, and we'll see you next time.
Thanks, everyone.
SQL Data Partners.